Yes, welcome back to the session. In this video, I am going to discuss about conical pendulum. Okay, so here I mentioned already a pendulum bob rotating horizontal circular motion. Then the resultant pendulum is called conical pendulum. Okay, so look at the first diagram here. So this is the object or bob of mass is m, which is connected with the help of massless string, and the other end of the string is connected to the rigid support. Okay, so we know that whatever it may be the position of the object, total weight mg will be acting vertically downward direction and tension will be acting upward direction. So this is when the object is at rest state. Okay, but according to the statement here, the bob is rotating in a horizontal circular motion. So look at the second diagram. So this is the bob which is rotating either clockwise direction or anti-clockwise direction in a horizontal circular motion. So whenever it is rotating like this, definitely it makes an angle theta with respect to the actual position. Okay, so at this location also total weight mg will be acting vertically downward direction. So I told you already, the spring having a tension, the tension is acting upward direction. Okay, so here this is theta, means if you extend a line in upward direction, so this is also makes an angle theta. So this component becomes t cos theta. So if this is t cos theta, means perpendicular component means this one. So this will be t sin theta. Okay, so this t sin theta, which is balanced by centrifugal force in outward direction, that is F is equal to mv square by r. Okay, so by seeing this diagram easily we can understand two things. T cos theta is balanced by the weight of the object mg, and t sin theta which is balanced by the mv square by r. So we can write it as t sin theta is equal to mv square by r. Let us assume this is equation number 1, and t cos theta is equal to mg. Let us assume this is equation number 2. So after getting these two equations, I am going to divide 1 by 2. Let's see what will happen. Equation 1 means t sin theta. So t sin theta by t cos theta is equal to mv square by r into mg. So numerator m, denominator m cut. So the rest of the equation is v square by rg. Okay, so left side also numerator t and the denominator t cut. The rest of the equation is sin theta by cos theta. So sin theta by cos theta means that is nothing but tan theta. So tan theta is equal to v square by rg. Okay, but we know that the relation between linear velocity and angular velocity, so we discussed already, v is equal to r omega. But here in this expression we have v square term. So let us assume here v square means r square omega square, right? Now you can substitute this formula here. Tan theta is equal to r square omega square by rg. So what will happen? So numerator 1 time r cut, denominator r cut. The rest of the equation is r omega square by g. So tan theta is equal to r omega square by g. From this I am bringing this omega square left side. Therefore omega square is equal to g tan theta by r. So here omega square is there, no? If you are taking this square right side means omega is equal to under root g tan theta by r. Okay, so here omega is nothing but angular velocity. Okay, so just a second, I will go for next slide. So finally we got omega is equal to under root G tan theta by R, isn't it? So we know that time period versus angular velocity, because let us assume this is the initial position of the bob and this bob is revolving in a horizontal circular motion. After one revolution means definitely takes some time, right? So that is nothing but time period. So time period T is equal to 2 pi by omega. So this omega formula I'm going to substitute here. Therefore T is equal to 2 pi root, omega means a reverse term, so we can write it as R by G tan theta. Okay, so just a second. So look at this diagram here. It looks like one triangle, right? So here theta will be there. So I'm drawing here. So this is the bob and this will be the radius and this will be the length and this is the theta, right? So from this right angle triangle, sine theta means opposite side by hypotenuse. So opposite side means R by hypotenuse means L. So sine theta is equal to R by L. From this, R is equal to L sine theta. So this R formula, if you are substituting here, therefore T is equal to 2 pi root R means L sine theta by G tan theta. Okay, so in denominator we have tan theta term, right? So tan theta means what? According to trigonometry, tan theta is nothing but sine theta by cos theta. Let's see the next step. T is equal to 2 pi root L sine theta by G into sine theta by cos theta. So this cos theta will goes to the numerator. Therefore T is equal to 2 pi root L into sine theta into cos theta by G into sine theta. Okay, so look at this equation carefully. Numerator sine theta will be there and denominator also sine theta will be there. So sine theta will cut. Therefore T is equal to 2 pi root L cos theta by G. Okay, suppose let us assume if L cos theta angle is very small, then L cos theta is approximately, we can write it as theta. Cos theta is approximately, we can write it as theta. If you are substituting here, cos theta value is 1, okay, after 1. So we can write it as T is equal to 2 pi root L by G. Okay, so this formula, it looks like a simple pendulum time period formula. Okay, so I hope you understand. Thank you so much.